Well, hello, I guess we're going to try this here for the first time tonight, or this year. I guess we'll see how it works. This is day 40. I don't know why it says what it says right there right now. But if we go back to that, I will change that for you. It should be day 40 of the trimester. Now, today, we're going to discuss momentum and how it relates to impulse. We watched a video yesterday, or Wednesday in class, and they started talking about this relationship between momentum and force. And what I want you to understand is momentum and force are related to each other through impulse. And what really happens here now is we had that force was the change in momentum over time, and that was derived for you in the video. And he said that if you take both sides and multiply it by time, what you get here is force times time is equal to the change in momentum. Well, the way that momentum breaks down into is we have an initial momentum and a final momentum. And we've talked about things like this year, whether it was velocity final and velocity initial. And that's what this delta here stands for, is this change. So the change is we take the final momentum and subtract from it the initial momentum. Well, why is there a change in momentum? Well, the reason there's a change in momentum is for some reason at some time there was a force that was applied for an amount of time. If we apply a force to an object, it's going to cause that object to accelerate, which means it will gain speed or slow down. If it slows down or speeds up, its final momentum is going to be different than its initial momentum because its velocity should be different. So that leads us then to this equation that force times time is going to cause a change in momentum. And that can be found by simply taking the final momentum and subtracting it from it, the initial momentum. Boxers do this. MMA fighters think about this. When they're taught to punch through the person's face. And obviously, I'm going to guess most of the time they're not going to be able to punch through the person's face. But what you'll find is that they are indeed able to punch and increase the amount of time that that force is impacted on their opponent's face. So by doing that, they are really changing the momentum of that person's face. If it was standing still and they're going to hit with a certain amount of force, then if they can increase the time, then obviously the force times time is going to be much larger, which is going to increase the change in momentum, which is going to make that person's head rock back pretty drastically. I've done this in the past with group work. We won't be doing this today with group work. I'm just going to take you through the steps here. I don't mean to be insulting to anybody, but we've got two problems, and impulse is actually a fairly easy thing to work with if we stay with our equation. Both of these sides, both the left side and the right side, are equivalent to impulse. So as you see down here, we will get to it going here. So let's find the initial momentum. Well, the initial momentum is, what is its initial mass? Well, that's 2,000. What is its initial velocity before the collision? And that's 5 meters per second. So that turns out to be 10,000 kilogram meters per second. The final momentum, well, it still has that same mass. But what's changed now is its velocity. Notice that this cart hits a tree. For the most part, I'm going to assume this cart stops, so we can say that the final velocity is 0. So the final momentum in this case is equal to 0 kilogram meters per second. I forgot to label that up there. So how do we go about calculating this impulse? Well, we take the final and subtract from it the initial. And And in this case, the impulse is equal to PF minus PI, which is 0 minus 10,000 kilogram meters per second, which obviously doesn't take rocket scientists to find out that it's negative 10,000 kilogram meters per second. So when it comes time to find the force, here it says that the impulse is equal to this momentum final minus the momentum initial. So what we can do then is we can take this answer that we got for impulse and we can plug it in right there. And what that gives us then is we have some force that we don't know yet. The story problem tells us the time that this impacts. It's for a very small time. Is equal to this negative 10,000 kilogram meters per second. Divide both sides by 0.2. And the force in here becomes negative 50,000 newtons. As you can see, that's a lot of newtons that are being exerted on someone. For example, when a 2,000 kilogram car will run into a tree, just going 5 meters per second, which we've learned is about 10 miles per hour. The reason the force is negative is because the tree is pushing in the opposite direction that the person is traveling. All right, we have another problem worked exactly the same. At this time, I would advise you to hit pause and see if you can work it out yourself. Yeah, I'm just sitting here waiting for you to work at it. A couple of you I know get the calculator up. All right, here we go. Hopefully you've worked it out. The initial momentum in this case is going to be the 20 meters per second times the 300 kilograms. And you should get then 6,000 kilogram meters per second. The final momentum in this case is again 0 times 300. I know it's a little bit morbid, but we're still going to say this person's hitting this tree. That gives us a speed of 0 kilogram meters per second. This impulse is found by taking 0 minus this 6,000, which gives us a negative 6,000 again. We can take this, and if you plug it over here, you get force times 0.25 equals negative 6,000. And then the force turns out to be negative 24,000 kilogram, oh sorry, not kilogram, well it could be kilogram meters per second squared this time, or just newtons. And for the most part, I'll probably just leave it as newtons. Again, it is negative. Why? Because it's going to be heading in the opposite direction that this person is traveling. For the most part this time now, you guys have learned everything you need to know about momentum. We've talked about the different types of collisions. We've talked about impulse now. What's going to happen is you guys come into class on Friday. You're going to have an assignment. You guys are going to be great for the substitute. And you're going to then have about 25 minutes to work on past assignments, or if you already have this done. The other thing with that then is for like the last 35 minutes in class, you guys are going to start getting put into your presentation, into groups, new groups, to put together what you have learned, talking about the different types of forces, the normal force, tension, centripetal force, gravitational force, friction, talk about momentum. Something I don't have on here, which I might include, would be collisions. Let's get that working again. We have inelastic and elastic collisions. Tell me what you know. If you want to, make an example up. Use the rockets that we fired off. But we're going to have a couple of days to work on that. Have fun with it. You're going to like your groups. And I will see you tomorrow. Bye-bye.